Hello and welcome to this tutorial about how to set up an ESP32-S3 fresh out of the box as a CircuitPython drive. The ESP32-S3 CircuitPython workflow might be interesting for everyone who wants to program microcontrollers in Python. It is also good for beginners, as the workflow allows you to just drag and drop files onto the CircuitPython drive. If you take the development board out of the packaging, this is what it looks like. For this tutorial, we will only look at the RGB LED, the USB port on the bottom right, as well as the boot and reset buttons. Inside our computer we can see that there is no CircuitPython drive yet visible in the Finder. However, you can see inside the system report under the USB tab that there is an Espressif device registered. If you don't see your device, make sure you have not used the charge-only cable. Following the first link, we are able to download the bootloader zip from the CircuitPython website. To do this, we have to scroll down and press the button Download bootloader zip. The bootloader is the program responsible for booting a device. Booting is the process of starting a device, so this is the starting program for the device. Now we are going to use Adafruit's ESP tool inside a Chrome browser. It is a fairly easy way of loading the bootloader onto the device, but it unfortunately requires you to use Chrome. An easy way of installing or updating the bootloader is described above. In the following, we're going to go through these step by step. Inside the tinyUF folder you can find the combined .bin file. This is the file we're going to put onto the device. Now we are placing the board in bootloader mode. We are pressing and holding down the boot button, then we are pressing and releasing the reset button, and then we are releasing the boot button again. We are now following the remaining steps inside the ESP tool. We are selecting the appropriate baud rate, we are clicking Connect, we are selecting the right serial port or COM, now we are erasing the flash memory. This took about 21 seconds in real time. Now we can select our combined.bin file from the Choose a File button menu. Now we are pressing Program. And after the firmware update is complete, we are pressing the Reset button. After resetting our device, a new drive should be visible inside of our Finder on Mac. Now we are going to download a new UF2 file. We will be putting this file onto our device by drag and dropping it onto the drive. We should now see the small LED flashing. After this, there should be a CircuitPy drive visible. Now we are following the instructions on the ESP32-S3 Github page from ultranoise. First, we're going to install Thonny, which is a beginner-friendly Python IDE. This part should be manageable in other IDEs as well. Then we are downloading the necessary libraries for the ESP32-S3. If you don't plan on building a MIDI or computer music device, you probably don't need to download these specific ones. However, for the final test, we are at least going to use the NeoPixel library. Once the download is unzipped, we are going to copy the contents of lib into the folder called lib inside our CircuitPy drive. This is where the libraries can be stored that are going to be used within your ESP32-S3 project. You can see the light blinking while the device is receiving the contents. Now we open Thonny. Under Settings, we go to the Interpreter tab and select CircuitPython Generic as our interpreter. Then we are choosing the ESP32 port. A quick print test shows us that it's responding. To load a program onto the device, we are simply going to copy the blinking RGB light script from ultranoise's GitHub page. Make sure to remove the 2 slashes from line 6. After pressing the green button, we can see that our program is running on the ESP32-S3. This was the final step in our project. Thank you very much for listening.